Okay, so we're looking at number 1. It says how much braking force has to be applied to slow from a velocity of 5 meters per second to a complete stop. And I don't know why braking is spelled wrong. Sorry. Okay. All right, so we want to find out what's our force. Okay, we have a combined mass of 80 kilograms. We want to find out what's our braking force to slow from a velocity of 5 meters per second to a complete stop. Okay, so let's see what variables we have here. 5 meters per second, what does that tell us? Initial velocity or final velocity? Initial. Good. And what's our final velocity? 0. Good. What else do we know?
Time is 2 seconds.
Time is 2, and we know our mass is 80 kilograms. Okay. Let's set up our free body diagram here. Okay, we assume that we're basically traveling in the positive direction, so our braking force would be going what direction? Left, right? It would be opposing our velocity, so we're just going to call that F sub B for brake. Gravity is always acting. Are we on a surface here?
Yes.
Yes, which means the normal force is acting. Okay, so that's what our free body diagram should look like. When we apply a braking force, are we still pedaling too? Are we applying any sort of forward force?
No.
No.
I thought you meant, are you still pushing the pedal? I thought you meant like...
Well, no. Like, are you still trying to move forward while you're braking? No, you're trying to slow down. So the only force that you're applying is the braking force here. It doesn't mention anything about friction, which means we would ignore friction. If we were concerned about friction, what arrow or what direction would our friction be going?
Left.
Still left. So it would go like this, right on top, friction like that. Okay, but we don't have any friction here, so we're not going to include that. Okay, we want to know how much braking force. Are we trying to find a horizontal force here or a vertical force? Horizontal. So we don't really care about the normal force or the gravitational force right now. Okay, so let's set up our net force equation. Are we looking at the horizontal direction or the vertical?
Horizontal.
Again, horizontal. So we can put a little X there if you want to remember horizontal. You don't have to do that. Okay, the X is just to remind you these should only be looking at horizontal forces because we don't want to mix horizontal and vertical. Okay. Okay, so do we have any leftward forces?
Yes.
Any leftward any rightward forces? No, my bad. And leftward forces, we have our braking force. Okay, so it's 0 minus because that braking force is going in the negative direction. F net is mass times acceleration equals 0 minus the braking force, which we are trying to find, right? We're trying to find this variable as a whole. We know our mass is 80. Do we know our acceleration? Not yet, but we can find it exactly. So we've got two variables, one of which we can solve for using our kinematics variables. Okay? And what kinematics equation could we use? The first one, the easy one, right? The easy one. Okay, so my velocity final, it looks like this. VF equals VI plus AT. So 0 equals 5 plus A times 2. And that means, bless you, my acceleration is equal to negative 2.5 meters per second squared. And it's negative because slowing down in the positive direction. Slowing down in the positive direction. Okay. So now we plug that in right here. So 80 times negative 2.5 equals negative braking force. Okay, and if I've got negatives on both sides, I can cancel those, right? So my braking force is equal to 200 newtons. Okay? And the reason that braking force is positive is because it's a still positive force. That's the magnitude of it, right? That's the size of it is 200 newtons. We draw it in our free body diagram going in the negative direction, so we don't have to include that in our answer, right? The negative doesn't go with the magnitude. The negative just tells us direction. So since we have it in our free body diagram going in the negative direction, we can just keep that. All right, so let's start looking at number 2. Okay, so this skydiver has a mass of 90 kilograms. Before he opens his parachute, so as he's free falling, he experiences an air resistance force of 190 newtons. What's the net force acting on the skydiver? Why, all right?
No, I'm not.
So let's make sure we start this with a free body diagram. How many forces do we have acting on this guy? 2. Good. And what's good? Gravity is one of them. Air resistance is the other. It doesn't say anything about him moving side to side or anything like that. We're going to assume that he's just pretty much falling straight down. Okay? So when we set up our net force equation, we're just going to take upward forces minus downward. That's it. Upward forces minus downward. So we're solving for the net force as a whole, so we don't need to do any substitutions there just yet. Okay, we're solving for the net force, so we can just leave that. What's our air resistance force? 150, that's given to us, right? And our FG is mass times gravity, so we'll take 90 times 9.8.
882.
Okay. So do we see a net force of positive value or negative value?
Negative.
Negative, and it's 882 minus 1. 732. Okay. Negative 732 newtons is our net force there. So as we go down to solve for our acceleration, can we expect his acceleration to be positive or negative? Negative. Okay, if our net force equals mass times acceleration, we're going to take negative 732 equals mass times A. So he's falling at just a slightly lower rate than anything would be without air resistance, right? Without air resistance, what's an object's acceleration as it free falls? Negative 9.8. But here he's experiencing some air resistance, so his acceleration is negative 8.1. So he's accelerating a little bit slower than he would be if he was in free fall, which that makes sense because he's got air resistance on him, right? When he opens his parachute, what can you expect to happen to this acceleration?
It'll go way up.
Up or down?
Up.
Well, okay, not counting the negative. Is he going to start moving slower or faster? Slower. Okay, so the acceleration will decrease as he opens that parachute. Okay, it might decrease so much that he has a positive acceleration.
That's what I meant, like, saying up.
Yeah.